Hi class, today we'll be discussing states and properties of matter, chapter 3.2. Chemistry is the study of properties and behavior of matter. So now we're going to look at matter. Again, matter is anything that has mass and occupies volume, is composed of particles, atoms or molecules. Now we're going to look at it in a different way of classification, as in three physical states. We call them phases. One is a solid, which if you look over here, you can see there's a bunch of atoms and they're very tightly bound together. They cannot move. They can vibrate, but they can't really move out of it. There's not enough room. They have a definite volume and a definite shape. Liquid, as you see here, has more movement in it, but it is still attached to each other. So it has a definite volume because whatever you pour a liquid in, it'll take that shape of whatever that container is. And they're still attached, but with freedom. And the last one is a gas. This does not depict accurately a gas. They are in speed. They will take the shape of a container. They have volume and shape. However, they are very spaced apart. They do not like to be near each other. And unfortunately, this little GIF doesn't show the actual speed. They are very, very fast moving, extremely fast moving. But this still kind of gives a visual of what three of these occur as. So solids have a definite shape, a definite volume. Particles are so close together, they're in a fixed arrangement. They cannot move out of this arrangement. Particles that move very slowly, so you think of them more as vibrating. They can move maybe back and forth and a little back, sideways, but they really can't do anything else. Liquids, on the other hand, they have an indefinite shape, but a definite volume. Indefinite shape? It has a shape that takes of a volume of whatever the container is. Let me fix that because I realize I have it saying definite shape here and then indefinite shape up there. Liquid it takes the shape of whatever container it is, but it definitely has volume to it. The volume doesn't go away as you pour it into another container. It will stay with the volume. It won't disappear. But these particles are close together, but they are still able to move around. So that's where you get the fluidity, the flexibility with liquid that you don't have with a solid. And then gases have indefinite shape and indefinite volume. They take the same shape and volume of their container. So for instance, unlike the others, gas can be compressed into a small container, but if you open the room up, the gas will fill that room. For instance, if somebody walks into a classroom and they have perfume on and you sit on the other side, you will definitely, if it's strong enough, you will smell it because the gas will carry those perfume molecules and that perfume will fill up the whole room. So gas will fill up the volume depending on how big the container. It'll just keep going until it can't hit any further. Gases move very fast. The particles move extremely fast. I know this doesn't depict it, so imagine this going 10 times, 100 times faster. They're very far apart and they don't want to interact with each other. So comparison of solids, liquids, and gases. This is something you can go over. This is in your book, and it gives you an idea of the shape. So here we go. Takes the shape of the container is what I should say here for liquid. And all of them have a definite volume, except for this one will always expand out to whatever the volume is or be compressed in to whatever container will push it into. Arrangement of particles. Solids have a fixed, liquid are random, close, and gases are extremely far apart. Interaction between particles, solids are strong because they have to be. That's what keeps them in the solid state. Strong liquid because it's still together. And gas, eventually they don't want to deal with each other. Solid has very slow movement of particles. Liquid is moderate. And gas is extremely, extremely fast. So now let's test our knowledge of this. It has definite volume but takes the shape of the container. I would tell you that's liquid. Its particles are moving rapidly. Gases move faster than any of the others because solid can't really move, and liquid does so, but within reason. of staying in that liquid form. So it would be gas. Its particles fill the entire volume of a container. That is a gas. Unlike a liquid, if you think about this, a solid will only fit the shape of what it is. A liquid will take the shape of a container, but it will not fill it up. If you pour a certain amount of water into a pitcher, it's not going to immediately go to the top. A gas will. A gas will fill the entire container until it hits a boundary. Its particles have a fixed arrangement, that is a solid, and its particles are close together but moving randomly. Randomly is a liquid. They're passing each other, but they're still attached. Now we're going to identify the state of matter, solid, a liquid, or a gas for each of the following. Vitamin tablets, that's something that's a solid. Eye drops, that's a liquid. Vegetable oil is a liquid. A candle. Now, it doesn't say a lighted candle. It says just a candle. So we're going to call that a solid. And air in a tire is gas. So now we're going to look at physical properties. Physical properties are when you observe something, you immediately take in the shape. So if you look at a person and I ask you to describe that person, you would tell me maybe their height, their shape, what color hair, eyes, eye color, if they maybe glasses. So it's the physical properties that you see when you look at something. So in this state, we would look at gas, liquid, or solid. Is there a color? Is there an odor? If you know, apples, have a nice apple smell that go with apples, and so forth. So these are objects that the properties do not change with the object. The object stays. There's no real change in what's going on with this object. These are physical characteristics that you use to describe or identify an object. They also include boiling and freezing points and so forth. So let's look at physical properties of copper. So if you look at copper, you immediately notice it's a red-orange color. It's shiny. It's, if you had more time to research this, you would notice it's a solid at a certain temperature. And we'll go even a step further with knowing the melting point and boiling point. Why are these important? Because if you would continue on with labs, I'm not sure of your labs yet because I'm creating this before the semester has started. You will, in some labs, you will use melting and boiling points to remove impurities from an object. I'm not going to go into more detail about it. Removing something, because if you know melting points, you can melt something away from other substances, or boiling point. A physical change occurs, and this is a change of state. So it stays the item or substance or compound it is, but it changes the state of gas, liquid, or solid. Water is a very easy one because water goes into 3 different states. Solid as an ice, liquid as water, liquid, and gas, steam, vapor. But no matter what, if you look into it closely, it's still water, but it can change state. So these changed physical states, I'm getting confused, I apologize. They change the state, but they stay the object. So if I tear a piece of paper up, the paper is still a paper. If I break a glass, the glass is still a glass, even though it's been broken. Dissolving sugar in water, it is still sugar, because if I remove the water, the sugar will be there. So a physical change is the object, regardless what state it goes into, is still the item. For instance, if I have a piece of paper and I burn that paper, I cannot bring that paper back. It's now ash. So I can't go back into the physical state that it may have been. However, if I tear the paper up, I can put the paper back. It may not be fantastic, but I can put it back together. So when you're asking yourself about physical change, consider what the change is and ask, can you put it back together? And if you can't, most likely it's not a physical change. So here, let's take a look at this. Classify each of the following as a change of state or change of shape. A, chopping a log into kindling wood. It's still wood, even if it's cut up. So, I did all these at once. So let's just look at them then. Change of shape. Water boiling in a pot. It's going to evaporate, so it'll be a change of state. Ice cream melting. It is still ice cream. It's just will be in a different shape, phase. So change of state. Ice forming in a freezer is a change of state. And cutting dough into strips is a change of shape. Chemical changes. This is a chemical reaction. So we start with something. We start with one or more substances. And after a chemical reaction occurs, we have entirely new substances. They are not the same thing. Let's go back to a piece of paper. If I start with a piece of paper and I put it in the fireplace, I cannot pull that paper out. It is now ash. There is new products after this chemical reaction. So this is completely different than a physical change. This is no longer whatever it once was. So some examples are pennies tarnishing, burning gasoline, combustion reactions. You can't really pull anything and save anything from a combustion reaction. The reaction of hydrogen and oxygen to form water. Hydrogen is a gas, oxygen is a gas, but when they come together, they form water. And digesting food. So chemical changes are the process of which substances actually change. Chemical properties describe which changes will occur. That's our next page coming up. So here is some indications of a chemical change. During a chemical change, a new substance forms that has new composition, new chemical properties, and new physical properties. So if you think of water, we start out with hydrogen gas and oxygen gas, both gases. Yet, when we put that together, we have water that has entirely new composition, new chemical properties, and new physical properties that are completely different than what we started out with before the chemical reaction. Here are some indicators of a chemical change: a color change, odor change, so combustion, you think burning, production of thermal energy, heat. So if you fill a container that's had a chemical reaction, it might produce heat, might produce cold on it. Fizzing, foaming, bubbling, those are strong indicators of a gas being evolved from whatever it is that you are dealing with. When you see for instance, you open a soda, the gas, the CO2 is leaving it. Those little bubbles are the CO2. When the CO2 is gone, it's completely flat. Nobody likes flat soda. At least I don't. Sound produced, think of fireworks. Fireworks give off sounds if you have certain, chemicals there. Light given off, fireworks again. Precipitate formed. This is not in a sense of straightforward. Precipitate, if you have a reaction, had we been in lab, you would have done a lab or you would have checked for precipitates. Precipitates solid doesn't necessarily mean a huge solid rock. It can mean even small particles. So if you had a clear solution and you mixed another clear solution, and once you're done, you end up with these little white particles that are cloudy, that's a precipitate. It may not take a full solid form, but it definitely looks different than what it started with, and you cannot see through it. And oxidation, rusting. Iron will rust away. You leave a car long enough, it'll just rust away to nothing. They expect Dr. Bob Ballard, the person that found the Titanic, believes, I think it was him or James Cameron, I can't remember now, that the Titanic will probably, everything that can be rusted away will be gone in about 20 years. Chemical properties. This one's a little harder to describe, so I'm going to do my best here. Chemical properties that go with certain substances. So for instance, if I have a piece of paper and I wet it, over time, it's not going to rust. That is a chemical property that paper does not have. But iron, left alone, and let's say we leave water out, it will rust. So a chemical property goes with a certain substance. If that substance doesn't occur, then most likely you do not have that substance. So iron will rust in moist air. That is a chemical property of iron. But aluminum will not. So rust is not a chemical property of aluminum. So certain properties will happen during a chemical reaction. And if these certain properties don't happen with these substances, either you do not have that substance or the reaction's not taking place. So the ability to burn, paper has the ability to burn. It will burn very quickly. Ability to tarnish, that is a sign of silver. Silver will tarnish. That's very similar to rust. Ability to rust. It'll rust. Iron will rust away. It will become, so iron will, in the presence of oxygen, become iron oxide. So that iron is slowly being eaten away by the rust. It will disappear, in a sense, is the best way to explain it. Ability to decompose, ability to react with chemicals, instability, ability to acid-base reactions. So physical change is a process that changes the physical properties of a substance without changing its chemical composition. that means that it stays whatever it was originally. But chemical changes do not. You have new properties, you have new substances. They are entirely different than what you had as before the reaction. And here is just a list of some things, chemical and physical. These are in your book. Same thing here. All right, so let's take a look at this. Classify each of the following properties as physical or chemical. Ice melts in the sun. That's a physical. Paper can burn. That's a chemical. I'm not sure what happened there. A silver knife can tarnish. That's a chemical, and I must have fixed it. And magnet removes iron particles from a mixture. That's a physical. Oh, I got interesting here. So understand these. Read back those slides so you understand the difference between chemical and physical. And that's it. Thank you.